started. Today we're going to cover some other types of probability. So it's mainly just going to be it's kind of using the concepts we learned again, but applying them to different types of problems.
Okay. Okay, my voice is like dying for some reason. But we'll go to the homework review. One sec.
Okay, so first question. There are two groups of friendly aliens in a room, the Auds and the Buds. Okay, all the Auds know each other and all the Buds know each other, but aliens from different groups don't know each other. Aliens who know each other hug, while aliens who don't know each other shake tentacles. And if there's an equal number of aliens in each group and a total of 30 hugs occur, how many tentacle shakes occurred? So type your answer to this one in the chat. Okay, we're gonna give you like a minute or so. That's pretty close, I think. It's a little bit off. Okay, so I'll go ahead and explain. Okay, fine. All right, last try. Okay, you get one more try and then I'll explain. Well, actually, there's not 5 aliens in each group. Okay, so a total of 30 hugs are going to occur and there's an equal number of aliens in each group. So we know that half of the hugs are occurring with the Auds and half of them are occurring with the Buds. So basically, so if there's like 15 hugs or like handshakes occurring, then we need to figure out how many people are in the group. And we know our formula is like n times n minus 1 divided by 2 equals 15. So then n is going to be equal to 6 if you solve that out. So we know that there's 6 aliens in each group. And then they're going to shake hands with the people who don't know each other. So there's 6 Buds that each Aud. Okay, 6 Buds that each Aud has to go shake hands with. So then since there's 6 Auds, there's going to be 36 handshakes. And then you don't have to calculate the handshakes for the Buds because they're already shaking hands with all of the Auds, if that makes sense. So basically that just avoids doubling them. And the answer is going to be 36. Yeah, you got there. Okay. Problem 2. Go ahead and put your answer to this one in the chat. Yeah, so you guys are correct. The answer here would be 6 because so with the table one, remember we have to like divide by the number of rotations. And then the formula was actually like n minus 1 factorial equals 120. And then basically, you know, that 5 factorial equals 120. So n minus 1 equals 5, and then n equals 6. Because if you do like 6 factorial and then divide by 6, that's the same thing as 5 factorial. Yeah, exactly.
Okay, so the third one is, how many sequences of 3 digits do not have any 2 digits summed to 18? And you can just put your answer in the chat. So I don't really see any answers, but I guess I'll just go over it then. So basically, first thing to notice is that the question is asking for sequences of 3 digits. So it's not a three-digit number, like where the first digit can't be 0. It's just one digit followed by another one, followed by another one. So yeah, it's not a number. So now we know that the only way to get 2 digits to sum to 18 is to have them both be 9s, right? So then we know our number has to have at least 2 9s. But we also know that one of the possibilities is that it's just 999. So this number has just 9s as, okay, sorry, it's not a number. This sequence has 3 digits that are just 9s. And then this is just one possibility. So now we're going to count the possibilities where it's like, yeah, what Yolanda's doing. So there's going to be 99 something, 9 something 9, and then something 99. So each time we calculate, we have to remember that we can't actually put a 9 here because we already counted that up here, and we don't want to overcount. So the only options are from 0 to 8. So there's actually only 9 options for each of these digits. So once we add all of this, 9 times 3 is 27, plus 1 is 28. And we know that when there's 3 digits, there's 10 possibilities for each digit. So 10 times 10 times 10 is, what is it? Oh, 1,000. And then 1,000 minus 28 is your answer of 972. Any questions? No? Okay.
Okay, number 4. How many ways can Jordan distribute 13 identical pieces of candy to his 4 friends if he wants each friend to receive at least 2 pieces of candy? Okay, 56 is correct here. So since each friend is already going to get 2 pieces of candy, we can take away those pieces of candy. So 4 friends, 2 pieces of candy each, that's 8 pieces of candy that are already distributed. So we just get rid of that. And now we have 5 pieces of candy left. So then we also need to think of like how many dividers we need to separate something into 4, which we're going to need 3 dividers because now you have like 1, 2, 3, 4 spaces. And then we have 5 pieces of candy left. So I'll just draw them. 3, 4, 5. So how many total objects is this going to be? In this picture right here, how many objects is that? Yeah, 8 objects. So we're going to do 8, and then we're going to choose like where to place the sticks. So there's 3 sticks, so we're going to do 8, choose 3. And then that equals 56, if you calculate it up.
All right, last question. So how many paths are there from point A to point B if you can only move to the right? Okay, I see a 20.
Did anyone else try this problem and want to put their answer in the chat?
If not, I can just go over it then. Okay, so if you remember from yesterday, you basically have to, like, it kind of looks like this, like numbers written on these little corners. And the number on this final corner is your answer. So how we do this is you calculate like the number of paths you can get to each of these corners. Sorry, my voice is like actually dying. So, yeah. Wait, so can you talk, Yolanda? I like
Okay,
can't
I'll
talk
talk.
anymore.
If you want to draw, you can draw. Okay, so actually we can use like this addition method first, but for this specific problem, it's actually kind of faster to just like trial and error your way through. So I'll show that after we do like the drawing. So for drawing, basically you're going to find the sum of like everything to the left and from the bottom. So here, so for like this corner, we can only go from the left right here. So what number are we going to write there? We're going to write a 1, and then we're also going to write 1s all the way down here. And then it gets a bit more complicated. So here we have a 1 coming from this branch and a 1 coming from this branch. So we sum them together to get 2. And here we have a 2 and a 1. So we're going to add 3 right there. So this one doesn't have a connection. This corner right here doesn't have a connection right there. So we just put 1 from up there. And then this one would be a 2 right here. So this one would be a 4 because 1 plus 3. And then this one would just be a 1 because it gets that from over this branch right here. Oh, wait, sorry, that would be a 5. Okay, 5 because 4 plus 1. And then finally we get 2 plus 5 equals 7. So 7's the answer. But then another way to do it is just to just find all the paths, because this is a relatively simple one. So here's one way. Here's the second way. Remember, you can only move to the right. Here's the third way. Here's the fourth way. Here is the fifth way. Here is the sixth way. And this is the seventh way. Okay, so basically, so the question, yeah, I can see where you get confused by the wording, but like you still have to move, like you have to move this way to get to B. It's basically just saying, here, let me change the color to make it more clear. It's basically just saying you can't go like this. You can't like move to the left and then go like that. Like, that doesn't work. You have to go like only this way and only, oh crap. Okay, you have to go that way and this way to get to B. You can't go this way. That doesn't work. If that makes sense. Okay. So
So, yeah, okay. Today we're going to look at some other types of probability. So casework, and then complementary probability, and then geometric probability is what we're going to do today.
Okay, so we did like casework some other day, but this is going to be just kind of covering it again with some like differences, I suppose. So remember that when we're using casework, we're going to break the problem down into all the cases that meet the criteria. And this just makes it easier to solve. So first, we need to think about all the different ways for which the event can happen. And then we calculate the probability for those cases. And then finally, we add those probabilities together. We're going to add there and not multiply because like these are different ways of achieving the same event. So you just have to add those probabilities together. And here's an example where you would use casework. So if 2 fair dice are rolled, what is the probability the sum will be odd? Well, the only way to make an odd number, if you're adding two numbers, is if you do even plus odd, or you do odd plus even. And so then we just have to calculate the probability of rolling those things. So the solution for this, we're going to calculate the first case where A is odd and B is even. So we know that there's 3 odd numbers and 3 even numbers on a dice. And so there's going to be a 1/2 chance of rolling like each of those. So 1/2 chance of rolling odd for the first one, 1/2 chance for rolling even on the second one, and that's going to get a 1/4 probability. So our second case is just the same thing but flipped. So A is even, B is odd, and the same probability is going to be there, 1/4. So now that we have those individual probabilities, we add them together because they're basically like the same event. The sum is going to be odd, and that's going to get us 1/2. Okay, does anyone have questions here? All right.
Okay, so 3 coins were flipped, and what is the probability that at least 2 of them landed on heads? So do you guys want to like go through this together first? We'll have another example, so I think I'm just going to explain this one to you. So the at least, it kind of tells us that there's more than one case. So we have to divide this into like 2 cases. So if at least 2 of them landed on heads, then that means either 2 out of the 3 landed on heads or all 3 of them landed heads. So first case is that only 2 of them landed on heads. And using combinations, so this is where the order doesn't matter, we know that we need to choose 2 coins out of the 3 to be heads. So 3 choose 2 is just 3. And our so we're finding the probability of each of the cases. So the possible outcomes is 2 times 2 times 2 because there's 2 outcomes for each coin and there's 3 coins. So there's 8 possible outcomes. So the probability is 3/8. And then for our second case, where everything is heads, we know that there's only one way that all the coins will be heads. So then we also know that there's 8 possible outcomes. We just calculated it. So the probability is 1/8. So now we add them up to get 1/2. Any questions? No? Okay.
Okay, so example 3, 5 coins are flipped. What is the probability that at most 2 landed heads? So there's going to be 3 cases here. So to go ahead and name all the cases you can think of in the chat that will meet the criteria of at most 2 heads. Yeah, so like Charles said, you can either get 2 heads here, you can get 1 head, or you can get no heads at all. So let's see. So we're going to make 3 cases. And the case 1 is going to be no heads, which there's only one way to get no heads. So that's 1 over 32. And now let's calculate how many ways you can get 1 head. So does anyone know like what sort of strategy we would use to calculate how we'd get 1 head only? Or basically like your answer for how many ways we can get 1 head. Yeah, that's correct. So we're going to choose, we have 5 coins and we're going to choose one of them to be heads basically. So that would just be 5 choose 1. And then the second way, for the third case, that's going to be 2 coins are going to be heads, and that's just 5 choose 2. So if you calculate that out, that's going to be 10 ways. And so our probabilities were 1 over 32, 5 over 32, and 10 over 32. So we have to add those cases up to get a probability of 1/2.
Okay, so now we are going to practice. And just to like save my voice, I'm not gonna read these. But yeah, so just do those 3 and put your answer in the chat when you're done.
You have 6 minutes, so until 10:51.
And just like, I guess letting you know, we're gonna do this in fraction form, not percents.
Okay, so we've gotten a lot of answers. So let's see how
Okay.
to do this.
So we know that to get an even sum, so like all of these questions are asking for even sums, right? So to get an even sum, you have to do odd, odd, or even, even, right? So for the first one, for the odd, odd case, we know there's 9 numbers because it's 1 through 9 inclusive, which means like you're counting 1 through 9 too. So there's, what's it called? There's 5 odd numbers and 4 even numbers here. There's 9 numbers total. So for the odd numbers, there's 5, so 5 nines times 5 nines is equal to 25 over 81. And for the even numbers, there's only 4, so 4 nines times 4 nines is 16 over 81. And you add these two cases to get 41 over 81. I think some of you were like close. Yeah, I saw you did like 10 times 10 instead of 9 times.
Off by 1 counting error, guys. We went over that in day 1, I think.
And then the second one, for the odd, odd case. So remember here, since Jack is pulling out one of the balls and then Jill is pulling out a different ball, there, it means that once you pull one of them out, it's like not an option anymore. So for the first ball, there's 10 in the jar, right? And 5 of them are odd, so it's 5/10. But for the second odd ball, there's only 9 options and there's only 4 odd numbers left. So that's why you would do 4 nines instead of 4 tenths or something. So yeah, this one's a little tricky. So you would multiply those two, and then same for the even numbers. This time there's just 5 even, and 5 odd. So it's the same thing, and you add them to get 4 nines. And our last question is, you can see those wheels at the bottom, but for the odd numbers, the first wheel, there's 2 odd and 2 even. So it's 1/2. And then the second wheel, there's 2 odd numbers and then 1 even. My voice is dying again. So it's 2/3. And with the even numbers, you do 1/2 times 1/3, and you add them to get 1/2 total. I think some of you got that one. So good job.
Okay, so now we're going to go back over complementary probability. So don't worry, we are going to do some new things today, but I think it is good to get a review of what we've done before. So remember that complementary, there are a lot of problems where you can be more efficient than just doing casework. This is basically like the opposite of casework, where so if what you're looking for is harder to calculate than calculating like what you're not looking for, then complementary counting is going to make it easier, because if you look at the diagram, if you find the opposite of what you find and subtract that from the total probability, then you just get what you want to find. And that might just be a faster way of doing it. Yeah, so like Charles said, exactly. And so say, here's a problem where you would use complementary probability. So I roll 2 fair 6-sided dice. What is this probability that their sum is less than 12? So what should we find here? What is the opposite of finding things? What is the opposite of what this problem is trying to find? All right, read over the problem and think about what strategy we would use to solve this. Okay, it looks like Charles got the right answer. So type in the chat what you did, Charles, like what you found. That would be the
Okay. Well, there's only one possibility that it can be 12, which is 6 and 6, and there's 36 total cases. So 36 minus 1 is 35. So 35, 36.
So here, instead of just finding like every single way something can be less than 12, we just find the one way where that doesn't meet our criteria, where the sum is going to be 12, and we subtract that from the total number of ways. So like Charles said, the only way you can get 12 is if you get one, if you get a 6 and then a 6. And each of those has a 1/6 probability. So the probability of rolling a 12 is 1 over 36. And if you subtract that from like the total number of possibilities, you get 35 over 36 as your answer to the question.
Okay, so at the beginning of the day, there are 10 available parking spots, and each parking spot has a 1/2 chance of being occupied by the end of the day. So what is the probability that by the end of the day, at least 2 parking spots are open? So can you tell me like what would be the opposite, like what we would actually calculate and subtract from the whole? So if we want to know how at least if we want to know about the probability that at least 2 parking spots are open, then what is the opposite of that? Yeah, so basically, yeah. So there are less than 2 open. So if there's less than 2 open, then that just means that that there it just means there's no spots open or 1 spot open, right? So we split this into 2 cases. So the first one is that there are no spots left open, and that's just like one case out of 2 to the 10th, because there's 10 parking spots and each one has 2 possible outcomes, being occupied or being not occupied. And for the 1 parking spot, there's 10 ways to choose the open parking spot since there's 10 available spots. So 10 choose 1 is just 10. And the probability that we get 1 open parking spot is 10 over 1024. And at the end, we just add these to get 11 over 1024, and then we subtract from the whole to get our answer of 1013 over 1024. Okay, hopefully that made sense. Cool.
Okay, example 3. I flip 5 coins, and what is the probability that at least 2 land on heads? Okay, so Charles, sit this one out because I'm sure that you probably already know this, but I just want to make sure that everyone else is getting it. So type in the chat if your name is not Charles. Yeah, you can private message me. What is the probability that at least 2 of these land on heads? So we're not going to calculate at least 2 of them landing on heads, but what are we going to calculate to make this problem easier? Like the opposite of at least 2 landing on heads. What would that be? There are 2 different cases that are not going to fit this criteria. Yeah, okay, 0 heads is going to be one of them. Perfect. So like Gary said, less than 2 landing on heads. And like Sandy said, so there would be 2 cases that we're going to solve for, 0 heads and 1 head. Okay, I'm ignoring that. All right. Instead of adding up the probabilities for like getting 2, 3, 4, 5 heads, we're just going to use the complementary way. So no heads, that's going to happen okay, so calculating no heads, then that's going to be a 1 out of 32 chance. Yeah, guys, participate and Kayang will give you cookies, okay? And so for 1 head, there's going to be 5 options for which 1 coin lands heads, or you could do like 5, choose 1, and you're going to get 5. So then we have 5 out of 32 possibilities being 1 head. And so if we add them together, we're going to get 3 over 16. But wait, 3/16 is not the correct answer because remember we just found the opposite of what we're trying to find. Yeah, so we have to subtract that from 1. And that means that 13 out of 16 possibilities are going to have at least 2 heads. Okay, so just making sure you guys know like how we got 32. So we have 5 coins and each of them has 2 possibilities being tails or heads. So basically we just do 2 times 2 times 2 times 2 times 2, and that's 32 total possibilities.
All right, so you guys will have 6 minutes again to do these 3 problems. And just because we're like practicing complementary probability, like you can do these without using it, but please just like try to use complementary probability instead of just doing it like the normal way, basically. Or if you end up doing it the normal way, then just at least think about how you could use complementary probability for these. So you can have until 10:18-ish. So yeah, and once you get your answers, put them in the chat for cookies.
All right, we'll stop distracting you. Focus on the math, everyone. And remember, if you answer these questions, Kayan's gonna give out a free cookie. Okay, I think we should probably move on. We probably spent a bit too long on this, right?
I don't think it's been 6 minutes, but
Oh, it hasn't? Okay,
yeah, I said I'd give them until 18.
okay.
We'll
What
wait
minute?
1 more minute. I'm currently giving out cookies to people that are like
Oh,
doing well.
my God.
Some people are stealing my cookies though, which isn't nice.
Okay, I think, okay, guys, stop. If you don't stop, no one's gonna get any cookies ever again.
Only cookies from my computer are real. Others are fake. Okay, I think there's like, oh yeah, it's 18 now.
Oh, what the heck? So let's pretend like my screen time is not that.
Okay, so the first one.
Wait, I'm stuck now because I opened that screen. Okay, hang on.
Okay. Yeah, if you got them right, I privately messaged you cookies. So okay, so the first one, this one you could just do it normally, but if we used the complementary probability way, so the probability of being green is the opposite of what we want to find, right? And the probability of being green is just 25 out of 60. And then so you just subtract that from the whole to find the probability where it's not green, which is 7/12. And then number 2, so if we want to find the probability of the spinner landing on C, then it's if we find the probability of it landing on A or B, then we can subtract from the whole to get the probability for C. So for A and B, it's just you just add those two that they give you, and you get 3/4, and then you subtract that from 1 to get 1/4. Okay, and then for the last one, if we find the probability that no dice shows a 1, so the question is asking for at least one of them showing a 1. So if we find the probability for no dice showing a 1, which is 5/6 times 5/6, because there's only one 1 on a dice. So that's 25/36. And if we subtract that from 1, we get 11/36. So I think like actually more than usual, like a more than usual amount of people got this right. So good job, guys.
Okay, we're going to take a break to give you guys time to eat all the cookies you just earned.
Yep.
Okay, come back at 10:25. Okay. Break is over. Oh my god, I'm stuck on this again. Please let me move. Okay.
Okay, so we're now going to go over geometric probability. So it's just probability problems that involve geometry. So like throwing a dart onto a dartboard, something like that. So they show up a lot on tests, and sometimes they can be like really confusing and overwhelming. So we're going to go over how to solve them today. So, and to solve these, just like a basic overview, we just identify what the problem is asking, and then we usually have to calculate like the area of the shapes. Then, well, this is like for the area problems only. There's also sometimes like volume and stuff. But anyways, we divide our total area by the desired area to get our answer for the probability. So yeah, Yolanda's going to show an example.
Yeah, so like the dartboard we're talking about, the question, like a typical question might say, I randomly throw 2 darts. Each dart can only land in one area, so like one of the bands. And then what is the probability that I score at least 90 points? So take a look at this and type in the chat if you have any ideas as to like our strategy when we're going to solve this. Yeah, so one of the things we're going to have to do is find the area of like the whole dartboard. Think about some ways that you can score at least 90 points because there aren't that many ways. You don't have to find like the numerical answer, but just like type out your strategy. So what are, so I'll just tell you, there's 2 ways that you can get 90 points.
So like Yolanda's asking for just the 2 different ways you can get 90 points and not like how you would actually go about solving this problem just yet.
Actually, kind of both. So yeah.
But like, yeah, so the first step is like to see how you can get 90 points, basically.
So there's, okay, so let's go to the next slide. So we're gonna see at least here, and that tells us we can use a bunch of cases. So our cases are going to be that we get 1 dart on 50 points and 1 dart on 40 points. And case 2 is that we get both of the darts in that center 50-point ring, right? So basically, when you see problems, like you need to see the criteria, and then think about ways that criteria is going to be met. So let's calculate the probability of these. So the 50-point target, you can see there, it has a radius of 1. And remember how to solve for the area of a circle? It would be pi r squared. So the area of that is just 1 pi, because 1 squared is 1. Okay, and then the 40-point target, it has a radius of 2, but also half of it is sorry, not half of it, but like the middle part is being taken up by the 50-point target. So since it has a radius of 2, its area is 4 pi, but then we have to subtract 1 pi because of the 50-point target. So the area of the 40-point target is 3 pi. And then the entire dartboard, yeah, so we're going to also have to find the area of the total dartboard. And it has a radius of 5, as you can see, like with those black numbers there. It has an area of 25 pi because 5 squared is 25. And using that, we can calculate the probability. So the probability of a dart landing in the 40 ring is going to be 3 pi over 25, basically the area of the 40 ring over the total area of the dartboard, because we're basically pretending like it's just thrown randomly. So everywhere has an equal chance. And the probability of the dart landing in the 50 ring is going to be the area of the 50 ring over the total area of the target of the dartboard. So then that's 1 over 25. And so we're going to have to multiply those together. So say we get the first dart into the 40-point ring, the second dart into the 50-point ring, that would be 3/25 times 1/25. But remember, the opposite could also happen. We get the first one in the 50-point ring and the second one in the 40-point ring. So we have to do that. We have to double 3/625 to get 6/625. Oops, sorry. And then case 2 is when both darts land in the 50-point target. So that's going to be 1/25 times 1/25, which gets us 1/625. And we add those cases together to get 7/625. So the main challenge with probability questions like these is like, first you have to think about what you need to solve for, and then you need to calculate everything, and there's a lot of steps. So it's easy to make silly mistakes, such as forgetting to double 3/625 here. So you just have to try to be very methodical. Yeah, it definitely makes sense when you think about it.
Okay, so our second example is, so this time the dartboard is a regular hexagon. So this means all of the angles are equal and like the side lengths are equal. And so this is divided into sections numbered from 1 through 6. And so this is kind of just the rest of the question is, well, like the next two sentences are telling you about how big these sections are. So section 1 is double that of section 2. And section 5 is triple that of section 6. And a DT is blindfolded and throws 2 darts at the board. And assuming that both land on the board, so they're on the board and in a certain section, what is the probability that the sum is 10?
What does it mean sum is 10? Does
So-
it mean like section 1, dart 1 lands on section 6 and dart 2 lands on section 4 and that's the sum is 10?
Mhm. Yeah.
Oh, okay. So that means the air, okay, never mind.
So this one is just an example, so I'll walk you through this. So basically, we know like in order to get 10 using this dartboard, you have to either do 6 plus 4 or 5 plus 5. Those are the only two options. So our first, and we also have to use area, right? And we know that this is a regular hexagon. So we can divide these into 24 equilateral triangles. And these triangles like fit the criteria of the question. So for our first case, the probability of us getting 6 is 1/24 because 6 is one of those triangles out of the 24 on this dartboard. And for 4, it's 6/24 or 1/4 because you can count 5 full triangles and then half of one and the half of another one at the top, which add up to 1. So yeah, Yolanda's like showing us on her screen. So, and you just have to multiply both of those probabilities together to get 1/96. And we have to make sure to double here because we know that 6, 4, and then 4, 6 are two different possibilities right now. And then for our second case, 5 plus 5, we know that that is 3 out of 24 times 3 out of 24 because it's like 3 of those what's called triangles, which is also 1/8. And if you multiply, it's 1/64. And here we don't double because getting a 5 and a 5 is just one case, not two different ones. So add those two together and you get 7/192. So this one might have been a little bit confusing, but you just have to make sure you double when you're supposed to and don't double when you're not supposed to.
This makes sense when you say it out and draw it out like that, but when you're actually trying to do it on a test, it's just like it's not this easy because like you can't really draw it out.
And the big thing about this is just like noticing the equilateral triangles, because if you don't have that, then it's going to be like really, really hard.
Yeah. So, and unless the question like tells you that it's regular or not, like you can't always just assume that it is regular and just divide it up randomly because the figures aren't always going to be drawn to scale. So this, like we did this right now because the problem tells us that this is true. So that's just something to note.
Right.
Okay, and our third example is, so a random point is chosen on the line below, and then points A and B are 6 inches apart from each other. What is the probability that the point is less than 3 inches away from point A, but greater than 4 inches away from point B? So we'll also walk through this one.
Okay.
Yeah. So we are going to mark the 1 inch marks just for your reference. So, and we know that the question tells us the point is less than 3 inches away from point A. So the bottom like brace is showing us where that section is. So less than 3 inches away. And then also it has to be greater than 4 inches away from point B. So the top brace is telling us that. And when we look at those two sections, we see that there is an overlap, which is the blue area. So there's a 2-inch overlap. So the probability is that section over the whole, which is just 1/3. This one just kind of is more logic. 1/3 wouldn't be the exact answer. Why would you say that?
Oh, well, you have to choose like
Okay. No, well, yeah, like there's an area that it could be like directly, it could be directly on that border so that it is exactly 4 inches away from B. Therefore, it wouldn't satisfy the equation.
So it says it's greater than 4 inches away. Okay. So it's like right there, almost at like the 2-inch mark. And then, yeah, I see what you're saying, but like,
Whatever, it's a math problem.
it's like basically exactly there.
Okay.
And yeah,
Basically exactly there, but it's not basically exactly there.
I mean, that would just like be, yeah. Yeah, okay. So yeah, Yolanda's gonna go through the practice.
Okay, so in this circular dartboard shown below, the outermost circle has a radius of 8 centimeters, and each smaller circle has a radius 1/2 the radius of the next larger circle. Find the probability that a randomly thrown dart will land in the white area. So try this for yourself. It's a bit challenging. But okay, I'll give you a couple of hints and hopefully I don't reveal the answer while doing this. So it's going to be 8 centimeters. And then just remember the area of a circle is pi r squared. Okay, so Charles is correct. The answer is 13/64. So he gets a cookie. And so let's go over how to do this problem. So we know that this radius of this big circle is going to be 8 centimeters. And then each smaller circle has a radius 1/2 of the next larger one. So this big white circle is going to have a radius of 4. This smaller black one is going to have a radius of 2. And this white one is going to have a radius of 1. So now we just have to find the area of basically all these circles. So we're going to find the area of this white circle right here. Actually, okay, let's find the area of the whole thing, which is going to be 64 pi, because that's just the biggest circle. Okay, what am I writing? 64 pi is the radius of the whole thing. And then the radius of this white circle, sorry, not the radius of the whole thing, the area of the whole thing. And this white circle has a radius of 4, so its area is going to be 16 pi. But then we also have to take away this black circle that's in the white circle. And that one has an area of 4 pi. So basically 16 pi minus 4 pi is going to equal 12 pi. And then we also have to add back the radius of the smaller white circle. I'm sorry, not the radius, why do I keep saying that? It's the area of the smaller white circle, which is going to be 1 pi, because 1 squared is just 1. So 1 pi. And then we get 12 pi over plus 1 pi over 16 pi, which is 13 pi over 64. And then the pi cancels out. So you just get 13/64 as your answer here. So hopefully that makes sense to everyone. Okay, we're going to ignore this explanation because it's written a bit weird.
Okay, so our next question is, a spinner is divided up into sectors, and what is the probability that on a random spin, the spinner lands in a sector that has an angle of 45 degrees? So this is a pretty big hint, but the entire circle has 360 degrees. And the sector is 45. So that is a very big hint. And make sure to leave your answer in simplified form. So I see a right answer that is not in a simplified form. But yeah, you're like basically there. Okay, so I think the spam of 1/8 has given away our answer. So yeah, since there's 360 degrees total, and we're just looking at this small section of 45, we just do 45 over 360, which simplifies to 1/8. And just like on like all types of competition math, basically, you always want to have your fraction on lowest terms. So never leave it like 45 over 360.
Okay, so next question. A random point is chosen on a line. Point C is between points A and B. And AC equals 4 and BC equals 2. So what is the probability that the point is closer to A than B, but further from A than to C? So it's a little bit confusing, but think about it.
just a hint for this one, if it would help you a lot if you like drew this out and then tried to do like the section like braces we did on the example one we went through.
Like drawing the lines, pretend like it's a ruler and add
Yeah.
lines. Okay, so let's go ahead and look over how to solve this. So for the point to be closer to A than to B, it has to be like in the left 3 units of the line. So okay, I'm just gonna show everything and then have this up. So that bracket right there shows like where it has to be closer to A than to B. And then for the point to be further from A than to C, it has to be like on the right 2 segments. So you can see further from A, okay, yeah, further from A than to C. So it must be over in those 2 segments on the top bracket. And so the only region of overlap is that 1 unit right there that's highlighted. And so the probability here has to be 1/6. Okay, so there are actually some very complicated ways you can use geometric probability. So some, like the ones we've just done, are like very obviously related to geometry, such as with area and stuff. But other types of problems like aren't obviously related to geometry, but when you graph it out, it makes the solution. That's like graphing out those problems is the way to solve those. So let's see an example. Anna and Taylor would like to meet together at a coffee shop to have coffee together, and they agreed that once one person arrives, that person will wait for no more than 15 minutes for the other person. If the other person doesn't arrive within that time span, that person will leave. If Anna and Taylor will each arrive to the coffee shop sometime between 9 and 10 a.m., what is the probability that the two will meet together to have coffee? So on the surface, this seems like a very complicated problem, right? But we're going to make a graph. So on the bottom is going to be basically the time that Anna is going to arrive, and then us. And then on the y-axis is going to be the times that Taylor is going to arrive. And so we can make a graph that looks like this, which shows the overlap. So like basically, for example, when you're reading this problem, you can see, you can see that at 9:30, if Anna arrives at 9:30, let me get out the laser pointer. If Anna arrives at 9:30 right here, then Taylor must have arrived from 9:15 to 9:45 because that's within 15 minutes. And the same goes for like all the other points. So if Anna arrives at like 9:15, then Taylor has to arrive at between 9 o'clock to 9:30 for them to meet and have coffee. So then we have to use this graph to solve the problem. So the total area of the graph in minutes is going to be 60 times 60, which is 3,600, because it's from 9 to 10, and that's 60 minutes on each axis. So basically it's just like a square. And the shaded time, now you have to find the area of the shaded part, which is going to be like the time that meets the criteria for this question, where they're going to have coffee together. So what we do there, there are actually some ways to do this. So the best way to do it is just to calculate the area of these triangles right here. And so you can see like, okay, so the area of a triangle is base times height divided by 2. Right, so then the base is 45 and the height is 45. And so you do 45 times 45 divided by 2. But then you have to multiply that by 2 because of this triangle over here. So basically just 45 times 45, and that's going to get you this. So the probability that they're going to meet is 1,575 over 3,600, or 7 out of 16. Yeah, you could. Yeah, okay, you could do what Charles is saying, but like in some problems, you can't, they don't have like perfectly halved into these. You'll see in like the next examples. So that's why I didn't talk about that way to do it. But you can definitely do that for like this problem.
All right, so we are going to do another one similar to the one we just did. So Jonathan would like to pick two real numbers between 0 and 100 inclusive. And what is the probability that the numbers he chooses have an absolute difference that is less than 10? So an absolute difference just means that like the difference between those two numbers is just less than 10. So to do this one, so first of all, I want you guys to tell me like, so if I have my first number as like 25, then what is like the range of numbers that I can choose as my second number to have the absolute difference be less than 10?
It would be a 15 to 35, not inclusive.
Yeah, you're right. So hopefully everybody else understands as well. So using that logic, that is how we graph this like thick line, I guess. And we know that it's up to 100. From 0 to 100, both of the numbers are from 0 to 100. So we know it's like a square now. So we do the same thing we did last time. So we know the total area is 10,000. Then we subtract the area of the two triangles, and the side length of the triangles is 100 minus 10, which is 90. And there's two of them. So we subtract that from 10,000 and we find out that the area of the gray part is 1,900. So then we do 1,900 over 10,000, which is just 19 over 100. So this might be a little bit confusing at first, but as we go through more problems, this should make more and more sense.
Like for this problem, you can't really just count the units, right?
Yeah.
Okay, so Alex would like to pick two real numbers between 50 and 100. And what is the probability that the numbers he chooses have an absolute difference that is less than 14? Okay, so you can see on this graph, like the axes are labeled like the numbers in the problem. So on this first row, it can be between 50 and 100. So let's say the number he picks is going to be 62. So what is the range of possibilities that that will fit the criteria of being less than 14, having an absolute difference of less than 14 between that number and 62?
48 and 76, not inclusive.
Yeah. And you can also kind of see this, like there's not enough units on this graph, but if you imagine 62 being right here. Yeah, okay. But anyway, we use the same strategy to solve this. So the total area of the graph is going to be 50 times 50, which is 2,500. Okay, and then now think about the triangles. So what would be the length of the base of the triangle? And what would be like the height of the triangle?
-50 minus 45, possibly.
So basically, okay, so right here, like you see I've drawn it out. So the red part is what we're looking for. And then the total length of this side is 50. So then find the red part. So this total thing right here, I think I didn't do that well. This total thing right here is 50. And you can see that little bracket right there says what? And then you need to find this.
I said 50 minus 14.
Oh, sorry. I thought you said 50 minus 45 or something.
What? Why would I say that?
I don't know. Okay, sorry. That's what I heard. Okay, sorry. Okay. Yeah, you're correct. So 50
Man, this
minus
is so
14.
sad.
That's 36. Okay. And then this height is also going to be 36. And so then what's the area of this triangle right here?
The area of both of them would be 1296. Because it would be 36 squared divided by 2 times 2, since there's 2 triangles.
Okay, wait. So the shaded area. Yeah, right. You're right. So 1296 because triangle is just 36 times 36 divided by 2. But then we multiply by 2 again because there's 2 triangles. So yeah, and then we subtract that from the total area of the graph, which is going to be, and our answer is going to be like, okay, sorry, that's not our answer, but our answer is going to be 1,204 over the total area, which is 2,500. And that gets, if we simplify that, we're going to get that as our answer for the probability.
Okay, this is like our second to last question, so I hope more people will participate. And so the question is that Alex would like to pick 2 real numbers between 50 and 100 inclusive. What is the probability that the numbers he chooses have an absolute difference that is greater than 14? So this is like almost exactly our last question, but the less is changed to a greater. So I'm gonna wait a little bit for some answers. And since we just kind of did this, hopefully we will get some answers.
The answer previously was 301 over 625.
Okay. Okay, so the answer was indeed 324 over 625. And basically this time, instead of subtracting the area of the triangles from the whole, you just like find the area of the triangles and that's it. So we just did this, but the area of the triangles is 36 squared because the side lengths, like the base and the height, are both 36. So yeah, once you simplify, you would get that as your answer.
Yeah, because I basically gave you the answer.
Yeah.
Okay, sorry about that. Okay.
Should we do this one?
Yeah, I don't know. Maybe we might skip this one because it's kind of weird.
We'll
And
see.
then
Do you guys want to do this sort of more complicated one or go to the Kahoot? If we get like 3 votes, then we will do something. Okay, I see 1 Kahoot, 2 Kahoots.
yeah, okay.
Okay, 3 Kahoots. We'll go to the Kahoot. Okay.
Oh wait, let's
This is
move it.
our final Kahoot at Mathema. So, well, for this session.
Yeah, your last Kahoot.
The winner gets a free 1-year like subscription to my cookie shop, so you can get free cookies for a whole year.
Okay, I'll put the link and I'll put the code in the chat. Watch everyone join and leave. All right, come on, everyone, join the Kahoot. Okay. We'll go ahead and get started. And if you want to, you can join in the middle. Yep, so this one, segment AD is like 12 units long. Segment AB is 5 of those units long, so it's 5 over 12. Okay, good job, Shreya. Okay, so remember the question says not on segment BC, so that means it has to be on segment AB or segment CD. So that's 8 out of 12, or 2/3. Not size in the lead. Area of the large rectangle, so the shaded one. Okay, so this one, I think there's like some confusion, but you don't have to subtract like the triangle and the square. We were just asking for the large rectangle. So sorry if that was like, sorry if that messed you up. But basically it's just asking 7 times 5.
Wait, but you shouldn't you? Because that's the white area. The gray area was the square, right?
Yeah, you're correct, but like, okay, sorry. The question is just kind of weird. So really sorry about that. Okay, so this one, area of the triangle. This one shouldn't be confusing. This is just setting you up to solve like a geometric probability problem. Yeah, so it's 6. 3 times 4 divided by 2. I expect everyone to get this right. Yay, good job. Area of a square. Okay, now hopefully you remembered all the answers you just gave. Yep, so this one is 6 out of 35 because you just do the area of the triangle over like the area of everything. So that rectangle question probably just should have said like the area of the total shape or whatever. Okay, it will land outside of the square. Yeah, so this one, you just have to subtract away the area of the square, which is 4, from the total area. Yeah, so the probability of landing in section C is 1/3 because the whole area is 360. So 120 over 360 is 1/3. Who put math for that one? I want to know. Yeah, so this one, not landing in section B. That means it can't be in this like 30-degree slice. It can be in this whole 330-degree slice. And if you do 330 over 360, that simplifies down to 11 over 12. So be careful, don't pick yellow because it's not a fraction. It's not even a probability at all. Okay, so that time might have been a bit short, but the answer is 3/8. So if we're going to calculate exactly 2 heads, then there's a couple of ways we can do it. So it can be like head, head, like that, or it could be head, head, like that, or it could be head, head, like that. So basically, I'm not going to go over, okay, you know what, I'm going to go over all of them, because why not? Head, head, like that.
Wait,
And-
I have to go early. Is that fine?
Yeah, that's fine.
Okay,
Alright,
bye.
see you. So then, okay, that's kind of messy, but you can see there's 6 total possibilities. And with 4 flips of a coin, that's going to be 2 to the 4th total outcomes. So that's 16. And then if you simplify that, you get 3/8. Okay, no one got this one. So here's one where I think you might use complementary counting. So basically, we're going to try to find a way where you're going to pull out no blue marbles. So the first chance of pulling out not something that's not a blue marble is 4/7. And since we just took out one of the ones that's a blue marble, the next one is going to be 3/6. So then that that turns into 6. Okay, I'm doing a bad job of simplifying this. 2/7. And then you subtract that from 1. The answer is 5/7, right? Yeah, the answer is 5/7. So that's the opposite of what we were trying to find. And then we subtract that from 1 to get 5/7. So this would just be the same thing, but 3 marbles. And the time limit's longer this time, so hopefully more of you guys get it. Oh, all of you got it. Okay. So very nice. All right, now this one is interesting. You actually don't have to do any math. Hint, hint. You don't have to do any math if you just think about it. Yeah, honestly, I probably shouldn't have given that hint. It makes it a bit too obvious. But you're drawing out 5 marbles, right? And there's only 4 marbles that aren't blue. So you're forced to draw a blue marble eventually. So that's going to be a probability of 1. Okay, this one, the time limit might be a bit too short. Okay, so most of you got that. So 4 students in a class didn't put their name on their homework. So basically we have like 4 pieces of homework and then 4 students. And so the chance that the teacher gets the first student correct is going to be 1/4. Then the second student is going to be 1/3 because there's 3 papers left and one of them belongs to that student. Second one is going to be 1/2. The chance of getting it correct. And then you multiply all those together. Okay, so this one I did not give a hint on, but it is 0 because so she hands back the papers correctly to 3 of the students. Then there's only going to be 1 paper left, and that paper has to go to that last student. It has to be the correct paper because there's only 4 papers and only 4 students. So there's no way she can only hand out 3 correct papers and get the last one completely wrong. Right? So it's just basically logic. Okay, nice job, Gary. Okay, the answer to this one is 11 out of 25. So let's see. We're going to find all the cases that will work. So we're going to find a sum of 2, a sum of 3, a sum of 5, and a sum of 7. We can't go any higher than that because the next prime is 11, and there's no way you can get 11 by choosing numbers between 1 to 5, right? So the only way to get 2 is to get 1 and 1. Okay, and then the ways to get 3 are 1 and 2 or 2 and 1. The ways to get 5 are 1 and 4, 4 and 1, 2 and 3, 3 and 2. And then the ways to get 7 are going to be 3 and 3 and 4, then the reverse of that, which I'm not going to write out, and then 2 and 5, and then the reverse of that, which is 5 and 2. Okay, fine, I'll write it. And so then if you count all of these possibilities, there's 11 possibilities. And the total number of possibilities is 5 times 5, 25. So 11 over 25 is the answer here. Okay, so let's see who's going to be winning Kayang's yearly supply, whatever, of cookies. All right, good job, Shreya. Good job, Gary. But it looks like not Sai has won the cookie
Yay.
prize. Congrats to the runners.
Good job, guys.
Yeah, overall, that's pretty great.
Okay.
0% correct.
So I guess Sai gets the cookies. So, and can you talk for this?
Yeah, okay. So again, we do have 5 questions of homework if you want more practice, but since this is the last day of class, we're not going to be going over it ever. So the answers will be sent out to your parents. And so since today is the last day of our class, we would really appreciate it if you filled out this form, basically just letting us know how we did in this course overall, and it'll help us improve if we make future math courses. So yeah, we both pasted it in the chat. And basically with all of that out of the way, thank you guys so much for showing up to class and participating. It was really great teaching you all, and so yeah, I hope you guys learned a lot throughout your 3 weeks here.
Thank you. Bye.
Wait, hang on, wait. I think there's something else.
There's actually
Oh,
Bye.
Yeah. Bye, guys. And
Well,
also, if you know someone who wants to help us teach who's in high school this year, they can apply if you just visit our website. So yeah.
yeah. Thank you for attending, everybody. Hope you enjoyed and learned a lot. And yeah, we will have another course in the fall, I think. So we'll have more info about that later.
Enjoy your summer. Bye, everyone.
Thanks for coming. Bye.
You bye.
Bye.
Bye.